Assalamualaikum warahmatullahi wabarakatuh and hello to everybody. We are from Group 10 would like to present our article critique on the article of design and implementation of a solar charge controller with variable output written by Charles Amimu Osretin and F.O. Odeko. Moving on, the abstracts for our article critique are based on the design and implementation of a solar charge controller with variable output written by Charles Amimu Osretin and F.O. Odeko. The aim of this article is to create an affordable, durable, and locally accessible solar charge controller for off-grid system. The method they use are they design a controller circuit with discrete component, including current booster, battery level indicator, charge controller, and power supply unit. To test the method that they use, they simulated a real-world testing that showed that the controller effectively regulated charging for a 12 volt for and 200 ampere hour battery. The results of this is that they obtain a gradual rise in battery voltage demonstrated by the controller's efficiency under varying sunlight condition. As for introduction, the reason why we choose this article is because we, as an electronic engineering students, can correlate with these topics easily, as we are an engineering students who mainly focus on electrical component. And what is in the presentation, we will explain what is being told in the article and what are our critique elements in the article critique. Last but not least, on how we will elaborate on the article, we will use our knowledge on the scientific inquiry we obtain on explaining to you guys about this article. Next, let us move on to the description of the article.
Hello, I'm going to talk on the description of the article. The research topic for the article is to design and implementation of a solar charge controller with the variable output of 12 volt for a 200 amp hours battery in off-grid solar systems. The authors is from Charles Aimiu Osaritin and F.O. Edeko. The project goals is to design a functional, durable, and economical solar charge controller. They mostly use discrete components and affordability for affordability and local sourcing. It creates a prototype for a commercially valuable products with battery protection. The problem addressed for the article is that the existing solar charge controllers might be expensive or unavailable in remote areas. Unregulated charging damages batteries and shorten their lifespan. And also, the benefits from the research is that they can protect battery from overcharging and deep discharge, extending their lifespan, make solar power a more valuable option for off-grid system with limited resources. The research question that I got from the article is that can a functional economical solar charge controllers be built using discrete components for off-grid systems? And also the hypothesis is that the solar charge controller designed with discrete components can effectively regulate battery in charging and extend battery life in off-grid system. The methods that they use in the article of the project is that firstly they design the circuit that which they use the discrete components like resistors, transistors, capacitors to create the controller circuit. Secondly, they build functional stages like there are 4 stages, which is current booster, battery level indicator, battery charge controller, and also power supply unit. And the third one is that for the component selection, they focus on affordable and readily available components. The fourth one is for simulation and construction. The design was simulated by using the Prometheus software after the calculations, and the physical controller was then built based on the simulation. And the last one, they also testing the circuit and the physical controller by taking measurements of the voltage and current by different stages, which at different points in the circuit to verify that it functions correctly.
Hello, my name is Ahmad Syahmi bin Rabbi. Today I'll be discussing the potential of solar charge controller using discrete component for off-grid system along with their limitation and areas for improvement. While these controllers show promise, one major challenge is their adaptability to varying battery capacities and the system size. To address this, we propose further research into optimizing the design for broader applications. Another crucial aspect is ensuring the reliability of locally sourced components. By exploring sustainable materials, we can enhance the controller's durability and reduce its environmental impact. Furthermore, integrating renewable energy source like wind or hydroelectric power into hybrid system can significantly improve energy reliability. In conclusion, continuous scientific exploration and innovation are essential to enhance the efficiency, reliability and sustainability of solar energy solution for global society and the environment. Today, I will be sharing observation and result analysis from a recent evaluation of a solar charge controller. Firstly, upon connecting the solar panel and battery leads to the controller, indicating the commencement of battery charging. Subsequently, after 12 hours and 20 minutes, the optimum charge LED illuminated, signaling a full charge, while the undercharged LED deactivated, affirming the completion of the charging process. This evaluation underscores the successful development of a low-cost, reliable solar charge controller. Utilizing locally sourced component, the product satisfactory performance make a viable solution for addressing power supply challenges within solar home system, particularly in Nigeria.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Hadri bin Sofian, and today I will be presenting about the critical elements regarding this article. So my group is doing a research on designing a solar charge controller for a specific battery capacity of 12 volt, or we can so-call of 200 ampere. There will be question about how well the controller design can be scaled or adapted to the different battery capacities. So this article should discuss the limitation in this regard and potential challenge in applying the controller to a wider range of scenario. Secondly, the article should mention the use of locally sourced affordable component, but it does not deliver deeply into the challenge associated with the ensuring the availability, the uniformly, the quality of these components. So a critic could discuss how variation in component quality or availability might affect the performance and reliability of the solar charge controller, especially in remote or resource controlled areas.
Hello guys, I want to draw some of your attention to two important areas of solar energy studies that I have identified. So the first one is the piece talk about making solar charge controllers with cheap parts that can be found locally, but it doesn't go into detail about how hard it is to make sure that these parts are available, consistent, of good quality. And this is very important because changes in the quality or availability of the part could affect how well and reliably the solar charge controller works, especially in places that are far away or don't have many resources. In dealing with this problem, it's necessary to make sure that solar energy system work in all places. And the second point that I want to explain is the piece talk about sustainability in the environment for a short time, but it doesn't go into detail about how the design of the solar charge controller affect the environment. It is very important to look at how the materials, production methods, and ways of getting rid of them affect the world. To keep this controller from doing too much damage to the environment, we need to know what their environment footprint is. Also, looking into other ways to lessen this effect is important for making of solar grid system that will last for a long time.
Assalamualaikum, my name is Nurfaiz and I will be discussing about the next critical element, which is the explanation of the design and testing of the solar charge controller and the potential future study opportunities. Although the article provides an explanation, it does so without going into the great detail about the methodology that were used, the validity of the calculation draws, the sustainability of testing protocols, and the reliability of the experimental design are all seriously questioned by this superficial treatment. In addition to undermining trust in the study's conclusion, the lack of a thorough explanation of the methodology creates a great deal of room for doubt about the reliability and rigor of the research process. Furthermore, a detailed analysis of the methodology would point out any possible problems and open the door for helpful recommendations meant to improve experimental methods in follow-up studies. The first understanding and application of solar charge controller technology can be improved by applying a critique like this, which explains areas where the methodology could be strengthened or alternative approaches explored. Therefore, an in-depth review of the methodology presents a chance to improve the scientific rigor and credibility of future research projects in this field, going beyond simply casting concerns on the validity of the study's findings. And next, the article's concluding remarks delve into potential future study opportunities, shedding light on areas that remain unexplored or require deeper investigation. Yet, a comprehensive critique has the potential to unearth overlooked gaps in knowledge and recommend research topics or concepts that demand attention in subsequent inquiries. Despite the undoubtedly valuable contribution this paper makes to the field of a great solar system, a thorough critical assessment can serve to not only identify areas for improvement, but also to enrich the study's breadth and depth. By meticulously evaluating its findings and methodologies, such critique can pave the way for more robust research endeavors and guide future exploration in this domain.
Lastly, I will take 5 main points to explain to you guys about our conclusion. The first one is the significance, the achievement, the test results, the constraints, and last but not least is the future research directions. For the significance is that this article researching on focusing on battery management and charging regulation. The achievement that they had gotten is that they have developed a practical and economical solar charge controller with a variable output using discrete components. The test result that had been obtained is that there had been used real-world settings that showed extended battery life and satisfactory charging management. The constraint that they had been go through is that they need to consider scalability, the component availability, and last but not least is the environmental sustainability. For the fifth point is the future research directions. To improve more on their future research, they can explore more on sustainable materials. They can optimize control designs for various battery capacities and system configurations, and last but not least, address knowledge gaps for improved sustainability and dependability and efficiency. And that's all from us. Thank you for listening to our presentation. Thank you.